Hello, in this video we are going to continue our lesson on transformations. In the last video I left off with vertical translations and hopefully recall that when you add or subtract a number from the function, it shifts it up or down by that many units. So this green dot right here goes with 1/3 x plus 0, so it went through the origin. But then when I add 2 instead of 0, it's the red graph, it shifted up 2 units so that the y-intercept was up here at 2. And then the last one here, when we subtract 3, it shifts that down 3 units. We also looked at so in general, adding a number k after the function is going to move the whole function, doesn't change its shape, just moves the whole function up k units. And if you subtract k, it moves the whole thing down k units. So we looked at a parabola. We have the blue graph here is the parent function for quadratics. And so when we graph it, we get a parabola whose vertex is at 0, 0, and you go over 1 up 1, over 2 up 4, etc. Reflect on the other side. So we get that blue graph, and then when we subtracted 5 from x squared, it just shifted that whole graph down 5 units. So instead of being the vertex at 0, 0, it's at 0, -5. And then we have the same exact shape. So you don't have a smartboard to do this with, so most likely. So you're going to go over 1, up 1. You're going to go over, from the vertex, you're going to go over 2 and up 4, which puts us at -1. And we're going to reflect those points over here. And if I went over 3, I'd go up 9 from the vertex. So the graph is shifted down 5 units. So the next part of transformations that we're going to look at are horizontal translations. And so if we graph this parent function, again, f of x equals x squared, this is the one I said, get this down, memorize this basic shape. It's got a vertex at 0, 0, over 1, up 1, over 2, up 4, over 3 would go up 9, but I'm off the graph paper, but just know where it's headed. Oops, I did not move over far enough on that point right there, but so over 1 up 1, over 2 up 4, more like that. Okay, so that is the parent function. So what happens when you subtract 1? Not after we square the function, but beforehand. So in the parentheses, if I take x minus 1 and I square it, and I subtract 1 from the x beforehand, if I just look at a couple points here, oops, it's g of x, so I'm going to call it g of x. We have, if I look at like going from -2, -1, 0, 1, 2, and you can also pick up a graphing calculator to put that in to see what happens. I'm going to do it by hand. If I put in -2 for x, I'm going to go -2 minus 1, which is -3, and when I square that, I get 9. If I put in -1 for x, -1 minus 1 is -2. -2 times -2 is 4. 0, if I put 0 in here and subtract 1, I get -1, which when I square it, I get 1. And then when I put in a 1, 1 minus 1 is 0, 0 squared is 0. And then we could keep going here, 2 minus 1 is 1, and then it starts going back up again. So it looks like our vertex is right there at 1, 0. So -2, 9 off our graph, -1, 4, 0, 1, 1, 0, and then it's going to be 2, 1, and it's going to go back up. So what happens when you subtract a number inside the parentheses before you square it is it shifts it to the left or to the right. Well, when I subtract, it actually shifts it to the right, which kind of seems contrary to what you might think it's going to do, because we're subtracting, but we're moving in the positive direction. But that's because to make this equal 0 to get that vertex, x would have to be 1. So it shifts over to 1 here, and then we have 1, 0. And likewise, we could make another table of ordered pairs, or you In general, what's going to happen is if I subtract a number, it's going to shift it to the right. And if I add a number inside the parentheses before I do the function, which is squaring, take a guess at what it's going to do. You could stop the video, make a table, and check it out for yourself, but it's going to shift 3 units. It's going to take this green graph, the original parent function, and it's going to pull it over 3 units to the left. So adding 3 makes it shift to the left. And when I subtracted 1, it moved to the right. So if h is a positive number, so if h is a positive number, the graph of f is the graph of y equals x squared, that parent function, translated if I subtract h, and remember h is positive, so an example would be like if you had f of x equals x minus a positive number 3, it's going to shift the graph. In general, instead of 3, we have h, shifts the graph h units to the right. So more formally, I said shifts before, which is really nothing wrong with saying that it shifts the graph h units to the right. But more formally, we could say it translates the graph h units to the right. A translation just moves the graph left, right, up, down. When I add h inside the parentheses before I square, it's going to translate the graph h units to the left. And if I add the k, and this is from the vertical translations, it's going to be a vertical translation up k units. So it just moves the whole graph up k units. And then this last one is when I subtract k after I've squared the function, so it's x squared first, not in parentheses, then I subtract k. That's when it's a vertical translation. It'll be down k units when I subtract it. Okay, so now if I put this together, if I have a function f of x, and then I take x minus h and square that, and then I add k, what's going to happen is it's going to move h units to the right and k units up, and when it's in this form, we can easily pick out what the vertex is going to be, because normally with the parent function, the vertex is at 0, 0, but now it's shifted h to the right and up k if h and k are positive numbers. And so what that means is that vertex will be at the location h, comma, k. And once you get that vertex, then you can just graph the parent function from there, from the vertex over 1, up 1, over 2, up 4, because we're squaring x, over 3, up 9. And so that's why I said get those basic parent functions drilled into your head so you can just remember what they look like and how to graph it and then shift it accordingly. Okay, so let's look at this. I want you guys to figure out what the vertex is, and then we'll look at how to graph some of these. So pause the video and write it down and then come back and check. So we're subtracting 3, and 3 is a positive number. Notice that in this format, it's x minus h, so my h is 3. So my vertex is going to be 3, comma, and then it's going to shift up 4 units, so it's 3, comma, 4. Okay, so, and then also we looked at this a little bit with linear functions. When I multiply by a number, it is a vertical stretch or compression. It's going to take the y-coordinates, and in this case, if I have y equals x squared, the parent function, if I multiply by 2, instead of it being the parent function shape, all of those y values are going to double because I'm multiplying by 2. So from the vertex, you're going to find the vertex. From the vertex, you're going to go over 1, and instead of going up 1, you're going to go up twice that. You're going to go up 2. Instead of going over 2 and up 4, you're going to go over 2 and up 8 from the vertex. So this is called a vertical stretch of factor 2. This next one is, because it's going to be 1/3 of the y distance from the vertex. This is going to be this multiplying by, so this is when we're multiplying, it's going to be a vertical compression. It's called a vertical compression of factor 1/3. Every y coordinate will be 1/3 of what the parent function was. So instead of going over 1 and up 1, I'm going to go over 1 and up 1/3. Over 2, instead of up 4, I'm going to go up 4/3. And over 3 and up 9, I'd go over 3 and up 3. So let's look at how that works. We're going to graph 4 functions here. 4, and then we'll be done with 8.5 video. I'm going to pause and I'm going to graph the parent function on 4 different graphs. All right, so the first graph here, I graphed the parent function for each of these, and now I'm going to graph the translated graph for this first one. We'll call it number 1, x minus 3 squared plus 1. So the vertex will be shifted. Instead of 0, 0, like the parent function, it's now going to be moved over 3 to 3, comma 1. So it'll be this exact same shape, moved over 3 units to the right and up 1 unit. So notice that the graph is, we have it at 0, 0, and then from that vertex, I'm going to go the same distance over and up from the vertex. I went over 1 and up 1. I'm going over 1 and up 1. Over 2 and up 4 to get to that point from the vertex. I'm going to go over 2 and up 1, 2, 3, 4. It's off a little bit, but hopefully you get that idea. And this would be over 1 and up 1, over 2 and up 4 in that direction. All right. The next graph, the minus 3 here is going to shift the graph down 3 units. So I'm going to have my vertex at 0, 3. But instead of graphing that parent function over 1 up 1, over 2 up 4, I'm going to go over 1, and because I'm multiplying, okay, let me back up. Adding and subtracting is going to move it left, right, or up, down, depending on if it's inside before you squared or afterward. And then multiplying is going to change the shape. So I'm going to go over 1, and it's a vertical stretch. So instead of over 1 and up 1, I'm going to go over 1 and up 2 times that. So over 1 and up 2 from the vertex on both sides. Over 2, instead of up 4, I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And that gets translated over here as well. So I end up with this graph. It looks narrower than the original function, but really what it is like if you just took and dragged it up or stretched it up vertically, it's going to be twice as tall. Okay, why don't you guys try to do these next two and check your work. Okay, so this was our third graph, so we call this graph number 3 and this one number 4. In graph 3, you're multiplying by half, so that flattens it out. It's going to be a vertical compression of factor 1/2. It's going to be half as tall as the other one, if you want to think of it like that. The plus 4 moves it to the left 4. That's a tricky one. So when you add a number inside, it moves it kind of the opposite direction than what it seems like it probably normally that you would think. So you're going to move 4 to the left, and then we're going over 1 and up 1/2 on either side, over 2 up, instead of up over 2 and up 4, we're going over 2 and up 2, and then over 3 and up 4.5 on the other side of the vertex as well. And then graph number 4, my parabola's in the way, but it was plus 2, plus 4, so it ends up being, or no, it was minus 2. This was a minus 2. And so the vertex moves to the right 2 and over up 4. So here's my vertex. And then since I'm multiplying by 3, I should have made this graph bigger, but I'm going over 1 instead of going up 1. I'm going over 1 and up 3. And I run off the graph paper here, which I can just kind of estimate where those are. And you draw that parabola, and every y coordinate is 3 times taller than the parent function. All right, so that is transformations. Bring your questions to class and we will go over them.